Welcome to video 1 of class 2. This class we're going to talk about functions of several variables and graphing in 3D. We're going to actually start with some basic definitions that we might have already known or we might need a little bit of time to review. And last year when we were studying linear algebra, we saw functions in general, and we discussed functions that map from Rn to Rm. And when we were talking about those functions, we actually labeled the input variables as the domain, and we also talked about dimension and all that, and then the mapping space, we called that the codomain. And then this year in Kali, Kali defines these just as we did last year. She also mentions injective and onto. However, when talking about range, Kali actually defines range to be the actual outputs. And when we were talking about this last year, we called this the image of f. Image of f. And in terms of set notation, we said that this was the set of all function values f of the vector x such that vector x is in the domain. Okay, and in this case it would be in Rn. However, we also talked about the fact that when we have a function, we might not use all of the domain elements. So just be aware that we could have a function f, that is actually over a domain D that is a subset, and remember that's the symbol for subset, of Rn, and then it could still map to Rm, as in Mary, just noting that Rm might not again be the entire space. It would just be the image or the range, and according to Kali. Okay, and so if we just kind of go briefly over an example here, we want to determine the domain and range of this function here. So at this level, before we dive in, we actually want to do a little bit of analysis, and we note that our function f that is given to us is on a domain D, and that's a D that is a subset of, okay, and then there's two inputs, so it's a subset of R2 and it maps into, and if we think about the output is, well, we're saying a function is that particular value, so actually the output should just be in R. Okay, and so then now with this analysis complete, we can actually go in and discuss the domain. And my shorthand for domain, and you can adopt whatever notation you prefer as long as it's clear, so I use this notation for the domain of f, just big D of f. We'll actually abandon this notation a little bit later on in the course, but for now it'll be okay. And we say that D of f is the set of all x, y, okay, because we have two input variables, such that, and then given the function, we also note that, okay, since it's a square root function, we need the x and y values, or the values underneath the square root, technically, which includes the 4. So we need 4 minus x squared minus y squared to be greater than or equal to 0. And just simplifying this a bit, x and y such that x squared plus y squared is less than or equal to 4. And if we were to graph this just quickly as an aside, we would see that, okay, well, when we have x, we have y, and so if we graph this, this would be 2 and 2, and we would have to make sure that for our input values, we're somewhere on the interior of the unit disk of radius 2. I should say disk of radius 2 in 2 dimensions. So that's the domain. When we think about range, range of f, and I'm going to use this notation for range. Oops. Range of f. Okay, so this is all output values, so I'm thinking R value. So normally it could be the whole real line, all real numbers, but actually if you look at this a little bit more closely, the maximum output we could get for f is 2, and the minimum value we could get is 0, and so then this is going to be our range from 0 to 2. Okay. And with these two things known, the domain and range, we have enough to construct a graph. And just a general definition of a graph here, it's an equation with inputs and outputs. And when we're working in 3 dimensions, we're going to have inputs of x and y typically. And then we could have output of z or whatever. And as long as we satisfy the equation, we're good. If we think about this in 2 dimensions, this doesn't differ any from what we already know. If we have x and y and we have an equation, x plus y is equal to 2, well, that's just going to be a slope, or a line of slope -1 that passes through these 2 points. Beyond this, you can extend this into any dimensions you'd like. And that'll be the end of this first video. In future videos, we're going to talk about how to take these definitions and extend them into 3 dimensions for our graphing skills to develop.